We are solving limits numerically. We've got the function f of x is equal to sine x over x. If we evaluate this function at 0, you can see here that we get 0 over 0. And so to actually find out what this value actually would be really close to, we use the concept of the limit. Let's take a look at the graph. Okay, so here's the function sine x over x. Got it graphed out, nice pretty graph here. And when we plug 0 in for x, we're getting a hole in the graph up here where the red dot's located, and it looks like that this hole is located at 1. But to find out where this hole actually is, we can use the concept of the limit, and we're going to look at this numerically. And so what we're going to do here is I'm going to take point 1, plug that actually into the function, so sine of 0.1 over 0.1 gives us approximately 0.99833. And then we get a little bit closer to 0, right, coming in from the right here of 0. We take 0.01, plug that into our function, so sine of 0.01 over 0.01 gives us approximately 0.9998. Now, as you can see here, that I'm getting closer and closer to 1, right, as my x gets closer and closer to 0. Now we can I could have done 0.001 and plugged it in, and you would have seen that we'd have got we'd be getting even closer and closer to 1, but I just stopped at 0.01. Now coming in from the left hand side, we take a negative 0.1 and we plug it in, and we get 0.99833. And we get a little closer to 0 coming in from the left at negative 0.01, right, and plugging that in, and you could see that we get even closer to 1. So you can see then we can probably make the assumption here that as we get closer and closer to 0 coming in from the left, right, our f of x is getting closer and closer to 1. And so therefore we can say that our limit as x approaches 0 is equal to 1. Now remember, this x approaches 0 means we're coming in from the left hand side and we're coming in from the right hand side, and if both of these values here are approaching, well, in this particular case happens to be 1, then we can say that our limit is equal to 1. So this is just in a numerical way of looking at the limit. Now this particular one right here is we're going to definitely solve quite a few problems using this fact right here, that the limit of sine x over x as x approaches 0 is equal to 1. Now we're going to be looking at this one here. We got our function f of x equal to the absolute value of x over x, and if we evaluated this at 0, we just end up getting 0 over 0. Now looking at the graph of this function, see, so here's our 0 on the x-axis, and if we come in from the right hand side, you can see then that it's a constant 1, and we come in from the left hand side, we can see that it's negative 1. Of course, by showing this numerically, right, so I plug 0.1 in, and 0.1, absolute value 0.1 over 0.1 is just 1, right, 0.01 over 0.01, right, you just get 1. But you notice I've got D and E here. This means it does not exist, and we're talking about the limit here does not exist. But coming in from the right hand side we get 1, but coming in, as you can see here, from the left hand side we get negative 1. So both of these are totally different, and that means that this limit as x approaches 0 does not exist. These must be the same for this to exist. Now if we were looking at what's called left-hand limits and right-hand limits, you see what we get.